I'm Paul Smeekes from TVO in Finland. I've been in the business for more than 30 years now at TVO, and amongst other, I've been taking care of vibrations, vibration problems, dynamic analysis, and stuff like that. And as for instance, last week, the price of electricity was on the negative side. This is actually the load follow is very important for us. So I have studied this subject of part load operation now. Yesterday, by accident, I looked into that for about 10 years. So there's a lot of things I've done, and in the last 5 years I've been studying with more effort even. And we are studying this, and I found out that originally the plants were designed, but I think it was mainly studied, let's say, with regard to the reactor, whether the piping systems, pumps, and reactor pressure vessel could handle this. It was not by no means studied from a vibration point of view, for instance, but also other things were not studied separately in that time. But the plant itself, the process is fit to do this. And I've gone deeper into this and studied loads and structural integrity for both the reactor island and the turbine island. Then the first thing you have to do is to establish the influence of part load operation on the significant process parameters. And these will be things like mass flow, temperatures, pressure, moisture content, and basically they are only in the main steam water circuit. Then on the outside, all the auxiliary remains quite the same. The next thing you start to do is look at the influence of these process parameters, and then you try to establish the damage mechanisms that may be there, and the effect of the process parameters then on the damage mechanism should try to rather to quantify, but sometimes this is not possible. But anyhow, you try to investigate what is the effect of the changes in the process parameters on these damage mechanisms, and that is done for all components in that primary circle of water and steam. Then
obviously we also start to then investigate what action shall we do. Do we need to make any changes, or do we need to make any monitoring, and do we need to do any additional analysis? And then obviously also economic risk has to be studied in the whole process. And here you can see this picture of part load operation. What is the important thing here? You can see the main circulation flow, the yellow one in the reactor pressure vessel, which will go down a little bit, and then the main flow through the steam, the red steam, and back into the reactor as water will also change. And that will actually mean that we will have a new operating point as well, and stuff like that. That means the people in our fuel department have had a lot of work to think about how to handle this from a fuel point of view. There are some other things. If we go to quite a low level, then we cannot handle this part load operation anymore with the internal reactor pumps that you see in the bottom of the reactor pressure vessel. But then we even have to handle it by putting in the control rods, which obviously also changes much, especially with regard to the usage of the control rods and to the fuel. But anyhow, I said I have to look on the influence of the process parameters, and this is just an example. We did this not only
we did not only make such a diagram for the flow, but we did it for the pressure, we did it for the moisture, and we did it for the temperature. So what changes occur? And when you see on the left side, it's called 211, that's a reactor pressure vessel, and up there we can see the turbine, and then all the systems in between with heat exchangers, pumps, etc., etc. So we have established the changes in all these systems, and then I have looked on the damage mechanism, which are on the next slide. So vibrations, that means we may get a risk for high cycle fatigue due to changed flow. The problem with flow obviously is that although the flow reduces, you may come into an area where some structural part has a resonance, or you can think about, for instance, a check valve. If the flow is low enough, then the check valve is not pressed anymore to the top of the valve, but it will start hanging somewhere in between, and then it may start to clapper, which means that actually we did analysis on that, but also we had vibration monitoring on that side. Well, there are some other items: erosion, thermal fatigue, chemistry, process stability. So all these things, at least as far as they consider my area of expertise, I had a look on, and I said it's quite a big project, and it's actually still going on with the probability of thermal cycling inside the downcomer of the reactor. That's still, I would say, that's the last active project. We looked at the damage mechanism from a component, system, and plant level. So as a summary, because I don't have a full presentation, I'm just starting up for the next presentation. The part load operation is possible when the following is considered: vibration, erosion, component performance, process stability, and we have to do monitoring, like for instance vibration monitoring, which is important for this group, but also chemistry and probably other possibilities of wear and tear that can happen in different areas that have been investigated by other persons at the TVO plant. So we studied vibration, thermal fatigue, chemistry a little bit, and we will monitor during the part load operation vibrations and chemistry. And that is how I started up now basically the next presentation, which is going from a more practical point of view into this part load operation. And as already was mentioned, we have all these publications on the Energy Forsk internet, and there is also one other publication on the load follower that has been made from a more theoretical point of view. So if you're interested in that, you can simply go to the Energy Forsk net website and load down that one. So I thank you for your attention, and if there are any questions, I think it's in about 3/4 of an hour that you will have the possibility then to go into this deeper. Thank you.